This video is about proving using a flow proof. So a flow proof is a different type of method to prove that triangles are congruent. So yesterday we did two columns, today we're going to do flow proof. So in flow proof, you have boxes. If we look down here, this is a flow proof. We have boxes, and in the boxes are going to be the statements, and under the boxes are going to be the reasons. So before we had statements in one column and reasons in the other. Now we're going to have them broken into boxes. So we're going to start the same way we would before, though. We're going to look at our given and mark what we know on the triangle. So we know that B is congruent to S. We know that E and R are right angles. Remember, when you have right angles, that means they are congruent to each other. And we have that A is the midpoint of ER. So that means A is bisecting the segment into two congruent parts. So this method would be angle, angle, side. So now we can start our flow proof. So if there's a statement that only has one thing and nothing can follow, it should have an arrow going to our end box. The more arrows and the more boxes like over here means that there's statements that build on each other to make a conclusion. So in this case, angle B is congruent to angle S. We can't do anything else with it. It's given, and that helps us prove that the triangles are congruent. Right angles are E and R are right angles. This is a given statement. Now, once we know they're right angles, we know that they're congruent. So in our next box, we would say they're congruent. Usually we need two steps to say we have a given and that the angles are right angles in the proof. With two columns, same thing with our flow proof. Then we also have that A is the midpoint of ER, which was given to us, and we can go one step further with that information to say that EA is congruent to RA, because a midpoint bisects a segment into two congruent parts. Now we have our three pieces of information that we would use to prove the triangles are congruent. So they all lead to the last box, which is our proof statement that says the triangles are congruent, and the method we used was angle, angle, side. So let's look at another flow proof. Number 2, they're giving us that WI and ND are congruent. They're also telling us that IN is perpendicular to WI, which means this is a right angle, and WD is perpendicular to DN, which also means that there's a right angle there. And then we also have a shared side in the two triangles, which is by reflexive property. So when I start filling out my flow proof, I know that there's one statement here that's given to me, and I can't do anything else with it, so it should just have an arrow to my final box, and this was given to us. There's another box with just one arrow, which means it's a one-step explanation, which happens with reflexive properties. So we'd also have WN is congruent to WN by reflexive. Now, in the middle, we have a lot of boxes, which is going to deal with these two statements. So each statement gets its own box. WI is perpendicular to IN. That was given to us. And WD is perpendicular to DN. That was also given to us. Now, when we have perpendicular lines, remember they make right angles. So our next box is going to identify the right angles. So angle I and angle D are right angles. And the reason we know that is perpendicular lines form right angles. Now that we know they're right angles, the next step we have is that they are congruent to each other because they have the same measure. So they're congruent because right angles have the same measure. And are congruent. Now that we have our three pieces, 1, 2, 3, we can use our last statement, which is that prove, and we can say that the triangles are congruent. So WIN is congruent to triangle NDW, and the reason why in this case would be HL. So number 3, ON is the perpendicular bisector of HR. So a perpendicular bisector does two things. One, it bisects the segment into two congruent parts, and it forms right angles, which is what this whole thing is representing over here. The two routes that we can take for the perpendicular and the bisector part of the statement. We also have reflexive properties, so ON is congruent to ON, so we would be using side, angle, side to prove the triangles are congruent. So in our longer area, I'm going to start with the first given, that ON is the perpendicular bisector of HR. So now there's two boxes because remember we need to identify our right angles and say that they're congruent. So we would say, if I just want to put angles on here with numbers, angle 1 and angle 2 are right angles. And we know that's true because perpendicular lines form right angles. And then we have angle 1 is congruent to angle 2 because right angles have the same measure and are congruent. Then the other part of our perpendicular was the bisector part. So in this box, we're going to use that the bisector created HN congruent to RN, and the reason would be a bisector cuts a segment into two congruent parts. And then the last piece that we marked that gets its own box is the reflexive property. So we have NO is congruent to NO by reflexive. So we can say that our triangles are congruent using the method side angle side. Our last proof. So PO is parallel to AN, which means if they're parallel, we can treat PN as a transversal. So these 2 point angles are congruent, P and N. We know that I is the midpoint of PN, which means it bisects this segment into two congruent parts. And bow tie problems, remember, always have vertical angles. So in this case, we would be using angle side angle. So I'm going to start with my given. PO is parallel to AN. Given. So I can say that angle P is congruent to angle N because if lines are parallel, then alternate interior angles are congruent. We also have our midpoint statement, so we can say that I is the midpoint of PN, which is given. And because I is the midpoint, then we know that it was bisected and there's two congruent parts. So PI is congruent to NI. And we can explain that's because a midpoint bisects a segment into two congruent parts. And then we also have that angle 1 is congruent to angle 2 because vertical angles are congruent. So we can end saying that our triangles are congruent now using angle side angle. So triangle POI is congruent to triangle NAI.